Dr. Juárez completed his PhD in animal production at the University of Seville in 2007. And before his PhD, he completed an MBA and a DVM at the University of Cordova. Dr. Juárez worked in research labs in Italy and Ireland and spent time in Finland working as a veterinary and production manager. After his PhD, he worked for a goat producer association in southern Spain, developing a meat quality differentiation brand. And in 2009, Dr. Juárez arrived to Canada as a postdoc fellow, and 2 years later became the Livestock Phenomics Scientist at AAFC Lacombe, where he continues to work today. So please join me in welcoming Dr. Manuel Juárez, who will be talking to us all about his work under the swine cluster. Thank you.
Thank you, everyone. I have a very boring presentation. That's why I also have a demonstration, so it makes up a little bit, because it's a lot between slides and tables and my accent. So anyway, I'm going to be talking about classifying pork primals based on quality traits. And let's do a bit of an introduction. This is preaching to the choir. You all know how important quality is in pork, but quality is defined by many different aspects, and quality for the consumer is different to quality for the packer or for the processor. But there are a few attributes that are common to all the different primals, and then we have traits that are specific for individual primals. So for example, in most studies, when we are looking at pork quality, we are focusing on the loin. Right? And usually color is the main trait. Marbling also has quite a bit of importance. And then we have fairness and purge loss, all these attributes that very often we assume that they're going to be related to color. So color is maybe the main attribute in loin nowadays. For other primals like ham and shoulder, the most important thing tends to be composition, fat to lean ratio, or the fat thickness in some of those primals. And then on the belly that used to be a low value cut and now is one of the most expensive cuts in the carcass, firmness tends to be the most important trait, and that is highly influenced by fat composition. So in this study, we focus on those traits in each of the individual primals, and then I'm going to show you some of the things that we came up with to measure quality. There are commercial devices, okay? So we were not trying to reinvent the wheel. If you want to do some of these testing, you can use, I don't know, the Meatmaster from Foss. It's great. It uses X-ray. You pass the primal through. It's going to tell you the composition and some measurements. But it's quite pricey, quite large to put in your plant. So sometimes it's not an option. There are other options, from hyperspectral imaging to ultrasounds. But in the project that we got with SIP, the idea was to do research and commercial testing and estimates for technologies for online pork classification. But the idea was to create accurate, low-cost devices that also were customizable and that could create low disruption in the plant. So if we have a device that is great, but it's going to slow down the line, or it's going to stop the process for a couple of weeks, well, that usually is not welcome in the plant. So we are trying to give options, especially low cost. This was my second project working with SIP, the first one where I was the PI. My experience has been great both times, and now I'm in my third project, now with Swine Cluster 4. I will talk about that at the end of the presentation. We were heavily involved with industry during this project. We had 4 big packers that met with us monthly for 3-4 years. SIP organized a big meeting in the middle of the project in Guelph, where we had people from industry, academia, from the different collaborators come and test some of the devices and have discussions. So we were not working in isolation. We don't work in a lab doing basic research. Everything was applied and then tested many times. And SIP was very helpful in allowing us to do so. Okay, so the first thing that we did was look at what is being done in the plants. Right? So if you have done any pork quality, either in research or in a commercial abattoir, you may have used the Japanese color standards. So I have them here. You have never seen them before. I have a new set that I got from Japan last year. Then I have an old set that we have used for a while. And I can tell you, when I go to the plants and I see the old sets, they don't look at all like the original ones in Japan. So that's one of the disadvantages of having these standards for a while. The other thing is these standards work great under fluorescent lights, but most plants now are using LED lights. And when you use different lights, colors look quite different. So we did some testing. The first thing that we did was, well, what happens when you use either the Canadian color ruler or the Japanese standards, and you measure multiple people usually measuring the same piece of meat. Well, when you have highly trained people that work together, have been trained together, you see there's a good trend. Usually there is 1 point difference from one to the other, but the regression is not bad. When you have semi-trained people, so that's what we did is we trained some students and we trained some people from other programs. Now you start seeing more difference. Now when you go to a plant and you have people that are rotating all the time and people who are training people and training people and training people, it's like playing telephone. We have seen some issues. The other thing is we see plants where they're using the Japanese standards, but they have them in a different location than the meat, so the light doesn't hit the same way. So anyway, we came with the idea of improving the standards. So this is not high tech, but if we can do something better, that would be good, right? So if you have used the Canadian ruler, the Canadian ruler is very good for marbling. For color, it's great when you're using it for image analysis. When everything is controlled and you take a picture, these are great because they were developed that way. They were developed with images in a computer. But they don't work great with fluorescent lights or with LED. So the first thing that we did was come with a set of colors that is specific for fluorescent or LED lights. Then the next thing that we did was play with formats. So this ruler is great for taking images, but it's not good to carry in the plant. So we came out with this other format we call the color fan. So now you can put a piece of meat in between two standards and see which one is closer to the one that you are looking for. And then on the other side, we have marbling, and we have another one with fat. So right now, this was 2 years of going back and forth because subjective scoring it depends on many things. So finally, we are ready now to print the new ones. So hopefully, we'll have some that you can get within the next month or so. And then the last format that I think, in my view, would be the most useful one is when you're in the plant, usually you don't care if your pork is class 1, 2, 3, or 4. What you care is that it's darker than the threshold that you have for your buyer. So you want it to be at least a 2 or at least a 3. So what you can do is you can take a sticker and put it in your sleeve. So as you are classifying the meat in the plant, if it's very obvious, you just keep going, but you are unsure, you just put the meat beside the standard in your sleeve. And then if it's darker or lighter, then you classify accordingly. And when you finish the shift, remove it, throw it away, take a new one in your next shift, so the color is always fresh. You don't have the issue of fading like you have with the bigger standards. So that was our first step. Let's go step by step from something very basic to something more complex. So how can we do color evaluation? Again, if you have worked in a plant, you may be familiar with the Minoltas or with other colorimeters that are quite expensive, big, but they are standard for research, so they are quite good. But we found other devices like this little Nix. It's actually from a Canadian company. So this is a colorimeter, but it was developed for painting. So you want to change the color in your walls, or you want to fix a patch in your wall, you can measure this, and then in your cell phone you have the actual color, and then you can go to Benjamin Moore and say, this is exactly what I want. But it's a colorimeter, so it works also with meat. So you want to measure the lean color. I come here, I click, and I end up with an image like this, and the colors in all the formats that you may want, LAB, RGB, what is the one, XYZ, so different color coordinates. They are actually color coordinates, but it sounds funny, but that's how it works. It's also very good for automation because this goes to a tablet, it goes all through Bluetooth, so you could connect it to a tablet, you can connect it to any device, and you get that information. Originally, we thought, well, this device, the cheapest version is $100. The most expensive version is $2,500. A Minolta is about $18,000. So we thought maybe they don't work that well, but we tested it, lots of numbers here. The important thing that you want to see is maybe Minolta versus these other devices, the Nixes. They actually have a higher correlation with the subjective evaluation than the Minolta. So, and then between themselves and with Minolta, they have a very high correlation. So you want to do color evaluation in your plant that you don't want to spend $20,000 in a Minolta, you can work with Nix. They are from Ontario, so also easy service from them. Now, for marbling, now when we're talking about the subjective evaluation for color, we saw that it wasn't too bad when you have people well trained. With marbling, it's not that way. Marbling, compared to IMF, they are not the same thing, of course. So marbling is the fat that you can see in a cut surface, and IMF is the actual fat that you have on the meat. Right? So there is a massive overlapping. So if this is the IMF, so you have around 4% IMF, you can have a person giving you a 1 and a person giving you a 5 or even a 6. So it's much harder because with IMF you are seeing the fat in the middle, in all the meat, and marbling only on the surface. So subjective evaluation of marbling is not great. So we came with options. Instead of using the little Nix for color, we use devices that use near-infrared spectroscopy. Again, this device is about $80,000. And these two were around $2,500. So we tested, do they work the same? Well, these ones are better for marbling. This one is not bad, but it's worse. Right? So it can be used, but we'll see the use of this one actually for fatty acid composition later on. So this is an option, but another option is image analysis. With image analysis, we can do both color, marbling, and linear measures. And you can see, you take a picture, and then it's gonna segment the link versus everything in the background, and then it's going to separate marbling in different ways and color. Anyway, it's a lot of process. We don't need to go into detail, but they work quite well. You can do with images in color or even gray scale, and it works the same. If you want to look at color, we saw you have a whole loin, and you look at the ends, it doesn't relate much to the center chop. But when you look at the back of the loin, the ventral side of the loin, it has a very good relationship with the center chop. For marbling, it's the opposite. For marbling, you want to look at the end of the loin close to the ham. That's the best way to predict the center chop. And if you are not familiar, we want to predict the center chop because that's the one that your buyer is going to look at, but we don't cut the loins, right? So you have to look at something outside to predict the center. Now, when we use image analysis with marbling and IMF, then we get a very, very good correlation over there. So how can we use this? We had a project with the University of Guelph trying to develop a system where we had a loin coming in a conveyor belt, and it passed through a little area where we have a camera and we control the lights, take a picture of that loin as it's coming through, and in a couple of seconds come out with the result. As a prototype, it works. Now we are not there for a commercial application. Where we are closer to for a commercial application is this funky device here. Looks weird. So this is basically a computer in your head. It's all voice control, voice activated. This is a camera, and actually right now I have the thermography camera on, so I can see who is warmer and who is colder. I won't tell, don't worry. But this device, then you have a little screen here, and it's all voice activated. So we have developed an application where you can put the meat like that in between your hands and say classify by color. It takes a picture, it processes in a couple of seconds, and it tells you it's a class 2 or a class 3. Okay? So this is what we call augmented reality or assisted reality. It's not full virtual reality because you are seeing the world, but it's giving you information. In fact, you don't even need the screen at that point. Everything is voice activated and with the camera. So right now we are at the process. It works quite well when you transfer from here to the computer and then back because we are using Python. But right now we are translating the coding into Android. So it will be all contained in the device. You don't need internet, you don't need connection online, you don't need anything to use it. So that's how potentially you could be using image analysis in the plant that can resist water and low temperature, and the batteries last quite long. So it's a device for that kind of application. So yes, hopefully sometime soon we'll be able to offer it to you. And then we go into firmness. We tried a lot of different approaches to measure firmness on the link. Nothing that I would recommend at this point. But in terms of the belly, we have a few options that I will show you today. Okay, so as I was saying, on the belly, fairness is important, composition is important. A belly like this is not good for Japan, but it's not even good for Canada either. Italians don't mind using that one. They roll it and they cook it like that. So it's not that you cannot do anything with those bellies, but in terms of high price, a firmer belly is going to be better. So the first thing we did was come up with an actual scale to mimic what is being done in the plants. So in the plants right now, bellies, even if they are very expensive, they are being classified subjectively. So somebody takes the belly and they do what you are seeing there. So you bend it a little bit with your hands and see how far it goes. So a belly that falls fully like that one, well, that's the lower scale for fairness, right? One that doesn't want to go, that would be a number 5. Usually the firmer the better. Now the problem usually when you have a very firm belly, they tend to have a lot of fat too. So that's a balancing act over there. So but we described how to measure those things objectively so we can train people always the same way. Next thing, we came out with a prototype. We came out with an idea of, you see this previous image, this bar bend method. That's what has been used in research for years. But you had to leave the belly there for 2 minutes, and then you had to measure the angle of the ends. You had to measure the distance between the ends. It's influenced by the length of the belly. So it's not a great system to do many bellies on a day. So we came out with a prototype of how to measure a belly real time. The first thing that we did was the first version of this model to see if letting the belly rest for longer change the final value, and it didn't. So that means that you could just go real time. As the belly passes, however it bends, it's going to give you the result that you would have 2 minutes later. Okay, so that's a good thing if you want to do something automated. The next thing that we did also was collect a bunch of different measures of different dimensions, thicknesses, widths, different things that we could relate to belly firmness, because belly firmness is a combination of many traits. And then we compare the traditional belly bend or bar bend with the belly bender, as we call this guy, and they correlate quite well as well. So we could keep going with that one. I will show you now how we do it, but this is the idea. You put a little needle, always at the same distance, at the end of the belly. That's this needle here. And then you attach it to the big needle and move the belly through. And then depending on how much it bends, it's going to come out, but at that time, it will move the needle, and then it will give you an angle. So if we want to do it in this one, you see how fast it is. Just put the needle there, and then move the device. Whoop. And then it's going to move your needle, and then this one will have an angle of about 18 degrees. Okay? So with that linear measurement, now you can actually take it into your database. It goes very fast. We had a project with a private company about 3 months ago. They were looking at a treatment that could impact belly quality, so we were able to evaluate 250 bellies in a couple of mornings. And the bellies don't get damaged. You can sell them. There's nothing. All this is food grade, so it's a very good system. So for research, it's great. We are using this. I will show you for the genetic study that we are doing now. But in the plant, this is not practical. So how can we do this in a commercial plant? Well, there we go, with conveyor belts that move by themselves. So this is just a prototype. I tried to have a company build this for me. It was about $70,000, and I didn't have that money in the project. So I bought 3 conveyor belts from China, and I modified them myself. So don't focus too much on how they look. But the idea is, you see, you have a very soft belly. Okay, this falls into a bucket. We don't want that for any processing later on. You have a belly that is relatively good. It gets picked up by the second conveyor. If it's very firm, it gets picked by the first conveyor on top. Now, this is a way of doing it. A simpler way of doing it is you can have your 2 conveyors where you pass your bellies from one location to another. Just create a gap. The very soft bellies will fall through the gap. You can put them on a bucket. If you don't have many low-quality bellies, they will just fall. You can remove, and the rest will continue going. And you can do that 2-3 times and separate different qualities, just playing with distances and speeds and angles. So these are concepts. In some plants, it may be easy to implement. In some plants, it may be harder. Now, the other thing that we did was to look at different technologies that can give us some more information about the belly. So the first thing that we did was near-infrared spectroscopy. Again, no, we didn't start with this device. We started with a very expensive one, and it seemed to work quite well to predict both subjective and objective firmness on the belly. Now, from there, we actually compared to a commercial device, like this one called Knit Foam, that measures iodine value on the carcass, on the hot carcass, and we tried to bring that to predict how the belly was going to behave. And it wasn't as good, but it was good enough to classify especially extremes. So you will be able you should be able to measure the fat quality on the hot carcass and identify extreme bellies, so the ones that are going to be very, very soft or very, very firm, and then you could cut the carcass differently based on that information. And then the next thing that we did was actually use the telespec, this little device, to measure the fat quality. So same thing, very fast. You come here, you have your calibration already open, click, and immediately you get a little spectrum there. And then click run the model, and it gives you in a couple of seconds. So that's a 65 for iodine value. So it's a very firm belly, as we saw. Also, it doesn't bend that much. It's also quite cold. So it was frozen a couple of days ago, so I'm cheating a bit. But it's a 65, so that's quite low. You don't want any iodine value over 72. That's the fattest as being very soft. But that's the idea. So there are people already using this one, and some people using this one for research. So there has been some adoption already of these technologies. And then the last one is looking at the ham and the shoulder. In the ham and the shoulder, you can use the same technologies. So we can look at fatty acid composition. We can look at color, of course. But then when we want to look at the actual primal composition, we came up with high to low level options. So the higher one is using our DEXA machine. So this is low energy X-ray. You pass the primal, and it's going to tell you lean fat bone content with high accuracy. From there, we came with different image analysis systems, like this one, where you look at the areas of fat versus the areas of lean. And then we came with linear measures. The idea of the linear measurements was to find maybe specific locations in the cutting surface of the ham where you could measure just with a ruler and give you enough information in a plant where you don't have time or money to have an image analysis system. And they work quite well. As you see here, they correlate. The image analysis data and the data from the DEXA work quite well. The area is better than the linear measurements, of course, but both work for that option. Okay? Now, how are we using those technologies now? So we have a new project with SIP. This time, what we are doing is using all these technologies to implement, to try to enhance pork belly quality across the value chain. So we have around 1,500 pigs that we're going to be slaughtering, animals from our own barn. We are working with a genetic company, Genesus. So the animals are pure genetics from Genesus, but they are the commercial Duroc versus Landras by Large White, slaughtered at commercial weight. And then we are looking at all these traits. We already have some preliminary results. We already know, for example, that there are a couple of measurements at the end and at the middle of the belly that have a heritability of around 0.5, what is very good for selection. The softness itself has also high heritability. So these are traits that could be selected for. The issue is, well, they have positive and negative correlations with other things. If you have a belly that is very firm, but it also has a lot of fat, your carcass is going to have a lower limit yield. But the heritabilities and the genetic correlations are not massive, which means that there is some room to do selection for those traits. So hopefully, in the next 2-3 years, we have results. The idea is to either modify a selection program to add some of the quality traits on the belly, or you could just, through genomics, select boars and sows that are specifically good for one trait or another, and then bring them to your farm and improve that quality. And then another project that we are looking into, this is funded by ARDAR. Again, we are using all these methods and a few more to collect tons of phenotypic information from the animals. In this one, we are looking at the impact of increasing slaughter weight. So I was commenting to a couple of colleagues. We have been doing some research on the data. You may know already Canada is the country around the world that is having a faster increase in slaughter weight. We are heavier than the US now, heavier than any country in Europe. So the average this last year is close to 135 live for slaughter weight. So that means that there are animals passing 150 kilos easily. In the US, it's more 125, 130. In Europe, it's still 110, 115. So we are quite heavy, and the trend has been to increase 1 kilo every year. So we continue that trend. In 15 years, the average will be 150 kilos. I think there will be a stop to that at some point. There will be some plateau, but it's important to see what happens when you increase weights. We are looking at it from a selection strategy perspective. So again, we are working with Genesis. What happens if you are selecting your animals for 120 kilos slaughter weight or 125, and they're being slaughtered at 150? What's happening in that difference of weight when the animals are being less efficient, they are accumulating more fat? What happens to the different primals? Again, with the idea of either modifying the selection plan or to be able to select different boars for different farms that want to go heavier or lighter in weight. But the idea is we are implementing all these techniques. We have all that information, so we are creating phenotypes that nobody had to this point. Right now, I have full phenotypes from around 3,500 pigs, and 2,500 of them have been fully genotyped with low-pass sequencing. We are doing low-pass sequences that then we can impute to whole genome. So that's very good genomic information. We are already seeing some results. But again, these two projects won't finish until a couple of years from now, maybe 3, depending on some of the tests that we are doing. So I'm going to leave it there because I tend to talk a lot. I'm going to give some time for questions. And if any of you is curious about seeing some of these things, I have brought also standards that the Americans develop with different ideas. I have the pork quality standards from Japan and a few other things. So maybe not right now, but after the presentation, if you have any question, we can go through them. Any questions? Okay, so in terms of the grading system, I didn't put anything on the presentation about grading in purpose. I have tons of information about different devices for grading and how the probes work and all of that. Some packers are still using the grading probe. Some packers are just paying based on weight, and some packers have other technologies. Most of those technologies for grading are focusing on the loin. So they relate very well with the lean to fat content on the loin, and maybe fat content in the whole carcass, fat to lean ratio. Now, when you are looking at things like quality, like color or firmness, grading has no relation, at least not a direct relation to those quality traits. That's why it was important to do this study. This study came originally from an idea from Canada Pork, where they wanted to have a classification system for primals that was going to be a national concept, but then talking to packers, it seems like they prefer to do things individually. So that's why we brought all the technologies. But there isn't a direct relationship to the grade from the probes or any other method. In terms of paying producers based on quality, it could be hard at this point, among other things, because when you're looking at the primal, there's no full traceability to the animal. You could do it by batch, you could do things like this, but for me, the thing is, if you are doing a better job at segregating your primals by quality, you are going to end up having the same high quality percentage of primals going to Japan or going to a premium buyer. It's just going to be different, the ones that go and the ones that stay. So there's not going to be potentially more revenue for the packer because they are classifying better. What's going to happen is your buyers are going to be happier. You're going to have a better retention of those buyers because there are not going to be quality issues. So going back to the producer, that would depend on how the plant wants to do it. I know a few plants that are paying right now based on iodine value. Right? Or at least they are giving either a premium or a penalty. The iodine value goes too high or too low. Because you can do it on the hot carcass and then go from there. So that's a way that these things can relate, but it has to make sense financially for the plant as well. You know, we haven't been making a lot of money in the last few years. So that could be something to look at in the future. Maybe you want to promote producers doing something different. Iodine value, for example, is one that is directly related to the diet. So it's a good motivation if you tell the producers don't use cheap diets that are going to increase iodine value and reduce firmness. So you can do that through payment. It's a good idea. But when we are looking specifically at the primal quality, it's hard to relate to the producer.